Hey everyone, and welcome. Every single time you click a mouse, type on your keyboard, or swipe on a screen, there's this entire hidden world working behind the scenes, managing literally everything your computer does. Today, we're going to pull back the curtain and meet that unseen conductor. So let's dive right in. So let me kick things off with a question for you. What do you think is the single most important, most critical program running on your computer right now? Seriously, think about it. Is your web browser? Your favorite game? Maybe that big piece of software you use for work? Well, the answer is probably not what you think, because the most crucial program of all is one you almost never actually see. And the answer is the operating system, or as we all call it, the OS. This thing is the invisible conductor of the entire orchestra. It's the master puppeteer pulling every single string. It's the very first program that wakes up when you turn your computer on, and it's the very last one to go to sleep when you shut it down. Now, that word right there, intermediary, that's the key to everything. Just think of the OS as a universal translator. You and I, we speak human, with clicks and drags and typing, but your computer's hardware, it speaks a totally different, really complex language of electricity and logic gates. The OS is the one sitting right in the middle, translating all of our requests into actions the hardware can actually understand. And then, just as important, translating the results back into something we can see on our screen. And this translator, it really only has three big goals. First, its job is to help you get stuff done, to run your programs and solve your problems. Second, it's there to make the whole experience as easy and convenient as possible. And third, and this is a big one, it has to manage all the computer's resources. We're talking its brain power, its memory, in the most efficient way it can. No waste. Okay, so we know what an OS is, but how do we actually talk to it? Well, the OS gives us a kind of window into the machine, and that's through its user interface. And for a long time, there have been two main ways to do this. On one side, you've got the command line interface, the CLI. This is that classic, black screen with text. It is incredibly powerful, but you gotta know the exact commands to type. But on the other side is the GUI, the graphical user interface. This is the friendly, visual world of desktops, icons, and mouse pointers that we all know and use every day, a concept that was famously pioneered at Xerox PARC. And let me tell you, this was a total game changer. It transformed the computer from a complex tool just for experts into something anybody could use, and it basically opened the door for the personal computer revolution. But that user interface, that's just the tip of the iceberg. Let's go a little deeper. Because behind that friendly screen, the OS is acting like the ultimate city manager, controlling and directing every single resource inside your computer. Check out this hierarchy. See, way down at the bottom, you have the raw hardware, the chips, the circuits, the metal. Then way up at the top, you have us, the users, and our application programs. And where's the operating system? It's that critical layer sitting right smack in the middle. It's the gatekeeper that controls and coordinates who gets to use the hardware, when they get to use it, and how. And its list of duties is just vast. It allocates resources, deciding which program gets the CPU's attention and how much memory it can have. It handles executing all your programs, basically bringing your apps to life. It manages all the input and output, and that's everything your computer talks to, from your keyboard to your printer to your hard drive. It organizes all your files and folders. And, so important, it provides security, acting like a police force to make sure programs play nice and don't interfere with each other, and defending the whole system from attacks. And that security piece brings up such a vital point. You know the old saying, a chain is only as strong as its weakest link? Well, that's exactly how it is with an OS. Protection isn't some feature you can just add on at the end. It has to be woven into the very fabric of the system. Because if there's just one weak link, the entire system can become vulnerable. All right, now for what I think is the OS's most magical trick, creating the illusion that it's doing hundreds of things all at once. It's this incredible high-speed juggling act that's happening every single second you're using your computer. To really get this, we need to understand the difference between a program and a process. A program is just a file sitting on your hard drive. It's passive, just a list of instructions. But the moment you double-click that icon, the OS breathes life into it, creating what's called a process. And that is an active thing that's actually running and doing work. So every single one of these processes goes through a little life cycle. The OS creates it as new, then it moves it to a ready line, where it waits for its turn with the processor. Once it's up, it's running. But let's say that process needs to grab a file. Well, the OS immediately moves it to a waiting state and lets another process have a turn. This constant lightning-fast shuffling between states is the real secret to multitasking. It's how your computer can stream music, let you browse the web, and pop up notifications all at the exact same time. And the OS has to be a really smart juggler, because not all tasks are created equal. Some processes spend most of their time just waiting for something to happen. Think about a word processor just waiting for you to type the next letter. We call those I/O bound. Others are just pure, heavy-duty calculation, like rendering a 3D video. Those are CPU bound. A good OS knows exactly how to balance both of these types of jobs to keep the whole system feeling snappy and responsive. But what happens when this perfectly managed system gets stuck? What happens when the juggling act stops and all the balls just fall to the ground? Yeah, let's introduce a problem into our little story. I want you to imagine a really narrow bridge, so narrow that traffic can only go in one direction at a time. And this bridge, it's divided into sections. Now picture two cars starting from opposite ends of the bridge at the same time. The first car drives onto the first section, it's claimed a resource. The second car does the same from the other side. Now they both need to move into the middle section to keep going, but that section is held by the other car. They meet in the middle, nose to nose, and they're stuck. Game over. Neither one can move forward or backward. That is a deadlock. So in the world of computers, a deadlock is exactly what we just saw on that bridge. It's when two or more processes are locked in a standoff. Each one is holding on to a resource that the other one needs, and neither one is willing to let go. And this isn't just some abstract theory. This is the reason why your favorite app might suddenly freeze up completely, or in a really bad scenario, why an entire critical system could just grind to a total halt. Now, this digital traffic jam can only happen if four very specific conditions are met at the exact same time. Resources can't be shared. Processes are allowed to hold on to what they have while waiting for more. Resources can't just be taken away by force. And finally, you get this circular chain of waiting, just like our cars on the bridge. Hitting all four of those at once is what makes deadlocks such a tricky, nasty problem for an OS to prevent or solve. Okay, let's zoom back out for a second. We've seen how the OS manages everything, how it juggles tasks, and even how it can sometimes get stuck. I think it's time we just appreciate the absolutely monumental role this unsung hero plays in all of our lives. At the end of the day, every single thing you do on a computer, from sending a quick email to playing a video game to exploring a massive virtual world, it's only possible because of the operating system. It is the fundamental layer. It's the bedrock. It is truly the unseen conductor that makes the entire symphony of modern computing possible. And that really leaves us with one last really fascinating question to think about. As our computers become smaller, more connected, and get embedded into everything from our cars to our coffee makers, the role of the operating system is only going to get bigger and more important. So what are the new challenges of efficiency, of security, of management that these future conductors are going to have to solve? That is something to think about. Thanks so much for joining this explainer.